All right, folks, I thought I would do a slightly cleaner version than the demonstration I did in class the other day. So we're going to take it from the top, really. So I want to look at the complete workflow right the way through from the installation of a fresh repository, right the way through to hopefully a validated pre-domain controller baseline, Git evidence trail, and the whole process end to end, really, which is what I'm looking for. And this is where we should be up to by the end of week 2, which is where we are now. Okay, so just a quick refresh of Moodle. The link to the GitHub repo is there. Announcements where I post, notice board where I'd love you guys to post stuff. Assignment brief is in there, and that's where the submission links will go shortly. Week 1, AD and overview tools. Those are the two main guides to set up the virtual machines. Um, just some links on PowerShell. And there's the stuff that we went through, and the Active Directory design guide. So this is the stuff that you needed to think about in order to be able to pull up the stuff ready to develop the workflow. And then this, the baseline. And then this is where we are here. So there's that workbook there, which contains all of the information we should have pulled out of your Active Directory design ideas. And there's papers there and stuff to read. This video will also appear here. Kind of meta. Okay. Okay, so the first thing we really need to be doing is heading off to the repo. So let's jump over. Oh, come on, Moodle. Don't be messing me about. No, gonna mess me about. Okay, so GitHub. Okay, and we want to go into the student repo, and we're just going to download a copy of it as a zip file, and I'm just going to save that into downloads. Okay, and then in downloads we can see it's there. So we should have an extract to. All right, and so as I've said before, okay, I'm going to create a dev repos. Try and keep your repositories outside of the user space. It's just something that Windows behaves mysteriously in places. Okay, so I'm going to select that there. Did that do it? Yeah, dev repos, and then extract those files out. Okay, and as we can see there, we're in our dev repos. Now let's just rename this to something sensible. Um, okay, so COM5411 pre-DC promo. Okay, that'll do. In fact, I'm just going to copy that because we'll need that in a moment or three. Right, okay, so now if we move over to the command line, okay, we should be able to cd into our repository. And if we look inside there, we can see that those are the files that are contained in our repo. And I'll run through those and expand on those in a little more detail. Okay, so still in the command line then. Okay, so now we've brought that down, but it's still not anything part of our infrastructure. So the first thing we need to do now is be looking at creating and setting up our Git infrastructure. Okay, so the first thing we need to do to bring this under the control of Git, yeah, is to initialize it. Okay, and we do that with Git init. Okay, Git initialize. Okay, and there we go, initialized empty Git repository. So if we look at Git status now, even though it says it's empty from its perspective, as there are no commits yet. it can see there are files and folders in that directory, but none of these are now being tracked at this moment. Okay, so in order to track them, as it suggests there, we need to use git add. Okay, and we'll do that. This will add everything in. You could add individual files and folders if you wanted to. Okay, and that's fine because this is just making sure that we translate the correct line end characters, as was noted in the install documents that you should have looked at. Okay, the difference between Windows and Linux file endings. All right, so now that we've got that there, now if we do git status again, okay, we can now see that these are all of the files that we want, and now Git has recognized those, and these are the changes to be committed. This is called staging. Okay, and as we look at the process in the GUI, you can see in VS Code which files are staged and which ones aren't. Okay, so that's at the process where we are now. So now let's do a git commit. Okay, okay, so initial, okay. Right, now, if you notice here, it's popped up, okay, because it's asked me for my password to verify and sign the commitment. It's signed that commit, okay, and there we are now. All right, so that's our directory structure expanded from the repo, okay, and turned into um, a GitHub repo of our own locally. Now, the next thing we need to do is we now need to push this back out to GitHub as our own repo. Okay, so there are a couple of ways to do it. You can do this from a template on, but I've not gone that way now. So if you're logged into your account, go to repositories, and then over this side, just click new repository. Okay, put the repository name, and if you notice, that's the one I copied from before. Okay, and that's the directory that we're in here now. All right, I'm going to make this private only simply because it's the one that we're demonstrating on. If you've logged in with your student accounts, it's worthwhile making it private too. Okay, we don't want any template for the moment. We do not want a README because we've already got in there. Not going to mess with the git ignore for now because we've got lots of files and there's nothing else needed down here, so we can just create that repository. Okay, it's got some useful hints and tips here anyway because we've already gone through this here. So now what we need to do is we need to now add our local repository to Git. So we need to link them together and then push them up. So let's just copy and paste this in because that's very helpful code. Okay, so git remote add origin. So what we're doing now is we're now linking our local Git to the remote site. Okay, okay, that's that done. We're now going to ensure that we create our branch, our main branch, which is what we're calling this now. So we're going to call it main. Okay, and then we're going to push the main branch back up to GitHub. Okay, and there we go. So now if I go into back to this repository, we should see everything in it. Okay, and that is now our copy, our student, my development copy, if you like, or your student copy of the repository that you need to be working in. Okay, right, brilliant. Okay, so let's now open this up into VS Code. Okay, so we're going to dot open VS Code, which opens it in the directory we're looking in. If we notice up here, okay, I'm in PowerShell 7 and there's a PowerShell 5 terminal, okay, and you can see that with the light blue and the dark blue there. Right, I'm just going to open up VS Code now. Okay. Oh, where did that go? Right, yes. Okay, it's waking up. Right. Okay, so the first thing we notice is obviously this is the VS Code we're all relatively familiar with, hopefully. Okay, but this is brought in now, and this is our folder that we have. So this is the terminal there and code, and this is the folder structure that we have there. Okay, so it's exactly the same. Okay, so really what I want us to be thinking about when we're looking at this, and certainly from a skills perspective, okay, is this is thinking like an enterprise operating system engineer, if you like, looking at enterprise environments. It's beyond the capabilities to be able to just run scripts, okay, and there are multiple tools out there that I've already talked about and mentioned, things like Ansible and Chef and all of these kinds of tools, and it moves away from that traditional admin approach of thinking in GUIs, yeah, hoping everything um, sticks together and then wondering why everything breaks down when it doesn't. So this really is looking at your enterprise infrastructure as code. Okay, and we're going to declare the state, and then we're going to look at it through our various different layers, and we've got these different layers here. Okay, so let's firstly start off, okay, with the overview of it. Okay, so the README. All right, this is the first thing that you'll see on the repository, and it takes you through everything that we've got through here. So have a look through that. Okay, it takes you through examples of the testing harness and absolutely everything in there. All right, so that's where that one is. Okay, so from the top point, we've got the documentation. Okay, this is where you can capture your design notes. Yeah, so structure for the organizational unit, group model rationale. This is our Active Directory design notes, if you like. This is ultimately the one that's going to be your README. Okay, so if you remember what we were talking about, you're going to build this up into the various different elements. Okay, and this tells you through what documentation you need to capture there. Okay, remember it links back to the assignment. Right, the next folder, main one down, is our DSC. This is the folder and the file that you work with. Okay, I will be adding information like I've put in here about how we handle credentials and various other different things, but this really is one of the only two files that you should need to edit. Okay, the other one is the all nodes file, which, as I've said, okay, this is the file that we pull down and is where we put our data. So this is, as we've been talking about in the lectures, this is the configuration plane. Okay, so this is where we tell what it is that we're going to do. This is the DSC logic. Okay, and then here is the values that go in there. This is just your data. Okay, as that PowerShell hash table. Okay, the outputs folder. This is where your MOF file, your MOF files. Yes, your MOF files will go. Okay, so once you've got all of those, that's where those compiled MOF files will sit in there. Okay, let's collapse that back up a bit. Okay, the next folder we've got down is our evidence folder. Okay, and this is where you will capture most of your evidence, and you can see how it's laid out. So there's bits and bobs there for your Active Directory. The AI log, okay, as I've said, you can use AI in this assignment under the strict conditions is that you must capture everything that you've done and explain how you've used the AI. Okay, so I would not like you to be using it to actually write code necessarily, but certainly to help with debugging and things like that. The DSC folder is just to capture outputs from the DSC. This is your Git and your logs, which we'll talk about. Your GPO backups. So there's various different folders here. Some of these folders and some of this information is pre-captured with me, okay, by the main script that we're going to talk about in a minute. Okay, so that's the evidence folder. Okay, the tests folder. This is where we keep our pester tests, and this is where we talk about the verification layer. Okay, so for these tests, to give you an idea of the test-driven development, okay, which is part of the process that we need to look at here, is I've provided that testing framework, and you can see the various tests here, including the one that we're aiming to get up to, okay, which is our pre-DC promo. Now, I'm not expecting you to write tests, but if you wish to write tests, I've provided you with a template there of what needs to go in the test and how to write it, okay? And the different ways that you can generate tests. I will let you know when a new test has been published to take you to the next level, okay? So that you can continue to work forward in this test-driven pattern that we're going on. And I will place those in here. So if I do any updates, I'll let you know, and it's likely to be tests to be placed in this tests pester directory. And we'll run through how to invoke and run the tests later. Okay. And then the other elements there is, like I said, that's the main README file. And then this is the orchestrator file. This is the entry point, if you like. Okay, and this is the one that calls the various different elements and tests. And again, any updates to this file as I start pulling in more tests, if you like, to be conducted at runtime. Okay, I will alter this accordingly as needed. So I'll let you know where they are. But again, just to recap, the only two files you really need to be editing are DSC configurations student config 1 as our config plane and all nodes.psd1 as our data plane. Our verification plane is here, okay? And the other documentation that we're going to put in place, okay, is the identity management layer is going to be driven with Active Directory on top. Okay, so that's the repo. Okay, that's where we are now with the repo, and that's what we'll work within. Right. Okay, so yeah, let me just recap that again. Okay, and I've just rearranged the screen just to make it a little bit easier as we move forward. So this one, DSC configurations student config.ps1. Okay, this is where all of your DSC resources sit. Okay, so this is where we're declaring what settings the system needs. So remember, we're doing this declaratively, not imperatively. Okay, so what we mean here is we're saying in here, install this feature, add this file, yeah, not run this command, which is what we would normally do with an imperative script. The other file, sorry, is the DSC data all nodes PSD1. So again, this is our hash table of parameters. These are the system specific values that we need to put in here. And why are we doing this? Well, this is our data plane, this is our data layer, and we're separating out the logic from the data. So stuff like computer name, network settings, features to install. Okay? So these are the two ones you enter. Don't mess around in here. Have a look by all means, please. This is completely transparent. If you do fiddle around in here, you're kind of on your own with that one, but that's up to you. You can debug it, you can roll it back. That's absolutely fine. Tests, if you wish to write your own tests, there's a template there which you can do so. Okay, and certainly from an infrastructure perspective, any folders with Git in there, such as .git and .gitignore, these are going to bring you plenty of errors if you mess around with things that you're not sure of. But by all means, please do investigate. And remember, don't forget the power of branching. Okay, so let's do some confirmation from the command line. Okay, so our present working directory. Okay, we're in dev repo, so we're in the repo, which is where we should be. I'm in PowerShell 7 according to that, but the other quick way to test it is PS version table. Okay, and we can see there we're in version 7.54, which is cool. Okay, and we know our paths exist because we can see those there. Okay, so that's good. Right, so we've already initialized the repository now with Git. Okay, but what we want to be doing now is we just want to check the status. So we're going to start looking at, and this is where Git comes in for the assignment about building up your evidence of what you've been done. Okay, so the current status, okay, is nothing. We're up to date. Everything is fine with there. Okay, and we can look at what branch we're currently on. Git the branch -v. Okay, and we're on the main and we can see our comment there, which is nice and useful. Okay, including your spelling mistakes are captured forever. All right, and this is what we should see. So git log one line -n5. Okay, which just brings us the last 5 commits, but this is a brand new repository, so that's what we expected as well. Okay, so this is a clean, nothing staged, nothing to commit. Okay, we're just going from the first point of the setup. And it's from this point is that you'll be able to prove and track your work. How does this reflect to industry? Well, often, especially from a cybersecurity perspective, you're expected to track and develop and authenticate yourself against um, uh, compliance and development, but also quite importantly, your future self as well. So when somebody ever comes up to you in the future and says, did you change this file? Did you actually do this? You've got evidence that you either did or you didn't. Okay, so it adds that element of security through security development. And there are documents and frameworks out there about developing securely. Okay, so that's our raw Git repo. Right, next, let's move on and run through and do the actual if you like, pre-flight checks. Okay, so we'll now get the infrastructure to test everything for us. Okay, so tests. Right, like I said, this is where we're taking a test-driven development approach. So these are the tests that you have to work through to verify the various different elements. And now we're just going to look at the pre-flight test, okay? Again, please read the notes through here, okay? Um, there's plenty of comments for you to look at. But this is the pre-flight test, and then we've got other tests that we can run and invoke and utilize as we move through this. So this is our pre-flight check. So this is the one that's going to check and test that the environment is ready to go. Okay, and we use this testing framework through our invoke validation script. Okay, so this is one that you will call quite regularly. And again, there's help in there in terms of there's different flags that you can push and pull depending upon what it is that you want to do. Okay, so the first thing we're going to do is let's run a test on this one. Okay, so tests. I don't want to do them all. Pester invoke. Okay, I'm just for this time. Okay, I'm going to do pre-flight environment dot test dot ps1. Right, okay, now whenever you're doing your tests, Okay, make sure that you do stick with the naming scheme. Okay, it's got to be tests.ps1. Anything else, it'll produce a false test, including that. Oh, execution policy. Okay, this is a weird thing. I don't understand why Windows does this, but it has an execution policy which you have on your um, machines, which allows or not allows certain execution rights for PowerShell script. Unlike Linux, where at root you can do anything, Microsoft still put other elements in place, and we can list that by get execution policy list. Okay, and there we go. We can see that these are vary, but the one we're interested in is the local machine one, okay, which is the execution policy across the local machine. So we want to be able to set that to unrestricted, really. So set execution policy, unrestricted, scope, local machine, and we want to force it as well. Okay, and we can check that again. Okay, and we can now see it's gone from remote signed to unrestricted. So hopefully my pester test should now run. Okay, run once. This might be a bit annoying. Okay, there we go. Okay, so we can see that's now running through the pre-flight check. So if you've gone through everything that was on the Moodle page that we talked about inside those toolchain week, okay, if everything runs smoothly, then this pester test should come through with everything looking green and funky like that. Okay, some things are amber and they're warnings, that's fine. Okay, but now if we run another pester test, okay, this time we're going to run one of the ones that we haven't started working towards yet. So let's say, for example, the DC Pro Mo one. Now, actually, before we do, I just want to get rid of this as well, I think, here. What it is this is the zone identifiers that Windows puts in place that identifies where some of the files that you've downloaded have come from. And in this case, it's just the enhanced security, and it's just saying run it, but ask me if it's from the web. So we need to unblock all of these files so that Windows doesn't think that this is web code anymore, and we've vetted it. Okay, so let's have a look, and the way that we really can enter that is, let's do get child item, okay, which is the same way as saying list path. Let's put the full path in. Okay, and then we're going to go from C colon dev repos com 5411 pre-cd. This is the one that we're in. Okay, we want to recurse. So go down the directory tree, and then we're going to unblock file. Okay, so that'll go down the directory tree and it'll unblock each of the files in there. So hopefully now, as we come on to run tests, we shouldn't run into the execution limits that we have within there. Okay, those steps, you might experience that, you might not. It seems to be happening across the piece. Okay, so that's the pre-flight checks done. Okay, just to show you how this runs with a false test, like I was saying, to show you what the negative outcome of this is. Okay, let's just invoke the pester test again. Okay, except this time, instead of running our pre-flight test, okay, instead of running our pre-flight test, we'll do our pre-CDOMO test. sorry, pre-DC promo test. Okay, and so pre-DC promo dot tests dot ps1. Let me check I've spelled that right. Pre-DC promo test ps1. Yep. Okay. So there we go. It's now running that pest test. Okay, and it's checked a bunch of stuff, and we've got a whole bunch of errors. Okay, but that's fine to be honest with you, because this is what we expected. So here it's saying internal NIC has static IPv4. Okay, that's fine because we wanted to test that. And we can see that there, that it's failed there. We've got an internal NIC which is passed, where we're looking at the length of the naming. So we can see how the negative tests work. There's the minus. And in addition to that, if you read them properly, okay, you might find some useful information there about how to fix those. Okay, so we know that this isn't anything to do with our environment because our environment is good. Okay, this is mainly to do with the fact that we haven't implemented anything yet to do with our promo. Okay, so that's the pre-flight check done, if you like. So we know the framework and the testing harness is run. Okay, so now let's just run our build main. Okay, so we're going to run our build main script once. This will run everything as it stands inside of the student config, okay, and inside of the all nodes data. Okay, and we should on our local, oh, it already exists, so let's get rid of that. Okay, so we should, when we run this, end up with a test directory coming in place and that folder. Okay, so we've seen this demo before, I think. Okay, so let's just run that now. Okay, oop, wrong one, and let it go through. Okay, so this is that build runner script running through the files. Okay, so this is that run build main running, which is calling our student configs. Okay, and then once it's done it, it's written the pest to test. It's written the moff file, which appears in outputs, student baseline, localhost moff, which you can see in there. Okay, but notice the output. Okay, this is where we've got that transparency in here. So what you're seeing is the process of what's happening, yeah, as the orchestrator sets up our DSC engine. So it's the things that you would have to manually be aware of and set up this as you were building your um, development and operations pipeline. Okay, so here we can see that we're enabling and we're ensuring that our DSC modules are applied. We're ensuring that our Windows remote management servers and system is setting up as part of the underlying DSC architecture. We're ensuring that we've got our remote server administration tools in. Okay, and we're checking everything else. Okay, we're compiling our student baselines and that's gone into there. Okay, and we can, there it is, a localhost moff. Okay, so we can see that now. Okay, we can see that. That's what we've run in and that's what we've done. And those changes have occurred on the machine. If I run the base run again one more time, okay, it runs through it even quicker because these already exist. Okay, and we can test that exists. All right, because again, we can invoke our test harness. And inside of our test harness, I've got just a very simple one here, which does as it says here. It tests whether the directory exists and it tests whether the file exists. Okay. and how we've done that. So in this case, let's run that one. Okay, and it's our test proof of life. Dot tests dot ps1. Okay, and if I run that test, everything passes. Okay, because yes, the directory exists. Okay, and yes, the file exists. Um, so that's also proven idempotency as well, where I can run this file, I can run that run build again many times, okay, and nothing actually changes on the system. Okay, if I delete that though, okay, that's deleted. We're going to run this student configs again. Okay, but before we do, I'm going to run the test first. Okay, this time our proof of life has failed because we don't have those directories in there. Okay, and we can see here, again, it's told you it's failed. Okay, so if you read that output carefully, okay, you can get some hints about what needs to be fixed on that one. So let's run it again. So this is the test, run, develop, test, run, develop, test, run, develop cycle, okay, until you get to a certain point. Sorry. Okay, I want to run build. So I want to recompile our moff file, okay, and then push that again. Run the test again, sorry. And there we see it's passed this time. Okay, so there we understand and we've got knowledge of the framework working. Okay, and this I think is a good point now to move into actually doing a full checkpoint in Git. Okay, so let's clear down the output there and have a look at this. So even though really we've not done any work yet as such, this is a good checkpoint. Yeah, the framework is working, everything's ready. You've got your environment set up. So let's mark that, let's check that. Okay, Git status. Now we can see here it's actually produced a whole bunch of evidence. Okay, so we've got in the evidence folder, these are flags which do the idempotency checks for the lower level local configuration manager. Okay, so that's pulled from the build one. So do keep those files in there, otherwise every time it'll run that check again. Okay, but what we've got here is the DSC logs, okay, which tells you when your moff file was created. There's some basic networking checks there, which just give you networking information. There's the pester tests, and these are in XML JUnit type outputs. Okay, transcripts there of what was run at the command line and the output from the command lines, so you can capture that and go back and look at that from debugging purposes. Okay, and then like I said beforehand, there's other bits and bobs of evidence that you'll want to put in here. So you'll want to put your ref log and various other bits and bobs in there. Okay, so for now, we need to do git add. We're going to add them all. Oh, actually, no, let's check it out into a different repository first. So this is branching. Yeah, so we're going to branch this to a different feature. That makes sense. So git checkout -b. Yeah, and we're going to put it into a different branch. Say, for example, -b automatically switches, by the way. And let's put this pre-flight verified. Okay, because we've verified our pre-flight checks. Okay, so that'll check us out and switch us to the branch, as you can see there. So now we can do git add. Oh, git add. Yeah, and you can do -a for everything, but okay, that works. Right. Okay, good. That's fine. That's as it was before with the messages coming back about changing the line endings. Okay, so the next thing we shall do now is we shall commit this as a checkpoint. So git commit -m. Okay, and I'm just going to put this in here as checkpoint. Okay, oh, let me just make sure I'm using the right keyboards. Pre-flight checks undertaken. PWSH confirmed. LCM configured. And prereqs all validated. Next steps. Next steps. We'll move on to baseline readiness. Okay, we'll commit that. Okay, now again, if you've noticed, it's asked me to sign that commit. Okay, so I've signed that, and there we go. So we can see there that it's created those elements in there. Okay, so that's where we are with that one. Okay, so look at that commit message as well that we've done. It's not just chucking in one line. Okay, you've got to be quite detailed with your commit messages. You can get, and I mean, although there's nothing to commit there really now at the moment, yeah, you can get your AI companion to do that if you wish. Okay, but why bother? But here, this is interesting. This is our Git point. So this is the initial checkout, and you can see this is the checkpoint in our new branch. Okay, and we can start to see our branching occurring when we look inside our Git graph. Okay, right. So back into our files now, and back into the one that we want to edit. Okay, so another quick check of our log. Okay, so git log. Let's just go back and do 3 lines. Okay, there we are. We can see where we're at. Okay, so there's our checkpoint and then our initial git. Okay, right. So that's our proof of life done. Let's move on to the next step. Actually, just thinking about it before we do, we should be able to pull information out from the Windows logs so we can see what's happened in there. So get win event. Let me accept. Oh, why did I start that? Win event. Yep, there we go. Log name. And I think the log name should be under. At least according to their documentation it is. Ten. Pipe that into, make sure you use the proper pipe key. Select. Oh, I see what we're missing. It's the thing I don't like about PowerShell actually. So get win events. Hold please. Okay, rather than watching me typing. Right, there we go. So that's that typed in now then. Okay, so let's run that. Okay, and there we go. So we can see there that the timer successfully run the LCM. Okay, and what particular triggered in there, or you can just filter that down as you look for that. So we can see there that we've got actual proof in there. And there's no errors in the DSC log at this time, so we can say that the local configuration manager did apply all of that configuration cleanly. Okay, so we've got everything else in there. So we have got that proof of life verified that we talked about. Excuse me. Okay, so now we're in part of this Git workflow. Okay, we've got that nice branch now that's a working checkpoint. So now each commit as we move along is a story about what works. And likewise, you can progress this smaller than I am. You can save these at certain chunks if you just start editing a file and save it and want to edit and add and edit and add. But do make sure that you add your comment messages in depth. Okay, so you know where they are. And then when you're pulling out your evidence as part of your write-up, you can pull that lot back. Okay, right, actually on to server baseline. Right, like I said, we're taking a test-driven development on this one. So the first thing I think we should look at here is in our tests, and it is our baseline tests. Okay, so, and this is kind of like where we start ramping things up a little bit. Okay, so again, there's a lot of this is preamble. Okay, but generally speaking, we've got a before block. Okay, which runs before we undertake any test to make sure that we're pulling in all of our data. And then these are the actual tests themselves. Okay, so this is where we can start actually validating configurations. Okay, and we can see here, yeah, we're validating here the host name matches declared intent in the all nodes. Okay, so we're actually checking now to see whether this information and this details are in our all nodes PSD baseline test, won't we? Yeah. Now I'm checking time zone because I've declared that my baseline, and this is a simplified one, you might want to add things into yours. Okay, but as a simplified baseline, we should be operating on a host name. It should have its time zone set to whatever time zone we declare that to be. But I also want to make sure that Windows 32 time service is running. Okay, so this baseline checks that the host name matches all nodes, as in computer name. The time zone matches are all nodes PSD1 file. Okay, and that we make sure that the Windows feature, Windows 32 time, is also installed. Okay, right. So this is undertaking some verification of that. So we're in here now where we can put that information in. Okay, so the first thing that we need to do, okay, and this is our all nodes hash table. Okay, well, let's add some properties in here. Again, we're declaring what we want the system to look like. Okay, so we've got that in there. Node name, localhost, DC, Bambas. We've got that information set in there. Okay, so we can change some things now. I'm going to change the domain name first because that's just putting it in as what it was. I'm just going to call mine bambos.local. So we know eventually we're going to be working in there. Okay, and we've got one role here as a DC. Okay, so let's set up some baseline configuration now. So in this case, we know that we're going to be doing a computer name. Okay, and I'm going to call that BBDC01, Bambus DC01. Okay, then I'm going to put in here our time zone. Okay, and I don't want specific standard time zone. GMT standard time. Okay, right. Okay, now I'm going to add some properties here just to show you kind of what we can do. We know from a baseline perspective, and we can set up different elements as a baseline as we move forward, but I know that this is going to be an Active Directory domain controller. Okay, so let's just put that and add those features in. Install adds role equals true. Okay, and that's going to put in our Active Directory. Okay, and install rsat adds also equals, not minus, also equals true. Okay, right, now you might notice there that we've already got that in place, okay, to some degree, but we've added that in there. So you see what we're doing here? We're separating that data from the logic. This all nodes, yeah, PSD1 file, PowerShell data file, literally says, I want the host name to be BBDCL1. I want the time zone to be GMT, okay? And I want to install the various different features that we're adding in there, okay? Okay, so let's recap where we were then, right? So we've got our test, our baseline test, okay? And what we're saying is I want uh, Windows time service with a time zone, okay, and a host name. So we're just going to test that. There's no values in here. We're just testing and testing and testing. Okay, our all nodes PSD1. This is where we've defined our data. Okay, so that's where we've put all of our data in there. Okay, and what it is that we're going to utilize with that one. Okay, the last thing I would put in, I forgot to put that in as well, is ensure. Uh, ensure W32 time. Okay, and we want that as well itself to equal true. Right. Okay, so we've got all of our elements in there that I think that we need to put in there now for what we want. Okay, the next thing we need to do now is we need to jump to our student configs PS1. Okay, so let's take a look and edit this one down. Okay, so this is the first thing that we need to be looking at, how we break this down. Okay, so the first elements that we see here is we use this configuration, student baseline. Okay, that's the name of it. Okay, here is our import resources that we import. Okay, and some of these are the ones that we installed through the standard setup process. Okay, and we've got these elements in here. And then this is our node block. Okay, so it's within our node block that we're going to undertake most of our development. Okay, so the first thing we're going to do is set up our computer. And again, we can set this up as we want. It's picking up, did you see that? It's actually picking up the majority of the data. Computer set name, in this instance, we can see what it's done there. Okay, set name, wrong brackets. Okay, name all nodes, computer name. Okay, so that's done what it says there. Okay, and we'll put a comment at the top there to highlight that in. Which keyboard am I working on? Not that one. Okay, and there we are. Why not? Take that as a good comment. Okay, right, good there. So that's that one do. Now we're going to set the time zone. Set the time zone. Okay, and again, similar kind of thing, time. Okay, and again, we can see some IntelliSense has kicked in here. So set time zone, set time zone. We do want that to set the time zone element from our all nodes. Okay, but we also need is single instance, as you can see there. Okay, yeah, and we need that. Okay, because we can only ever have one instance of a time zone running, as I've said before. Okay, the other thing we needed to make sure that we had in there, okay, was our service, our Windows 32 service. Okay, so service. Okay, and as we can see, we've got that there, but Windows time. Oh, Windows time. Okay, and then brackets. Let's just neaten my brackets up so I know where they are. Okay, so we're going to give it a name as Win32 time, which we know about. We're going to make sure its state is running. It comes in automatically on startup, but we're also going to add a depends on here. Okay, and we're going to say it needs to depend on the time zone. Okay, and for that we put it inside these brackets, and as you can see there, IntelliSense has found that for us. Okay, so what we're saying there is this time zone function, yeah, time zone, set time zone has to have occurred before we turn on the service. So we set the time zone and then we turn the service on. Okay, so that now links back to what we've done in here. Yeah, computer name, time zone, Windows 32 time. Okay, the things we now have to install as our ADDS role and our RSAT. If this was going to be a baseline for a web server, we might install IIS instead. Okay, so we're getting everything ready. We're installing everything that we need to run with first. Okay, let's keep editing down and back into our student configs. Okay, so Windows feature. Oh, let me again. ADDS role. Okay, I'm just going to call it ADDS though, because life's too short. Okay, and then we're going to give it its name as AD domain services, and we're going to ensure that it's present. Again, we're not saying run add install command from PowerShell. Okay, what we're saying here is make sure that the Active Directory domain services feature is installed on it. Okay, and then again, Windows feature RSAT ADDS. Okay, oh, let me get my squigglies in the right place. Okay, and there we are. So RSAT ADDS tools, and again, we need to make sure those are present. Okay, and again, I'd like to set up, okay, a depends, and there we are, Windows features ADDS. Okay, all right, so to very quickly recap then, okay, these resources that we've put in here, this is our configuration plane. We're telling it what it must be. It must have a computer name. It must have a time zone. It must have Windows time running on it. It must have ADDS installed, and it must have RSAT tools installed on it. Okay, that's all data. That is telling us what it is that we want it to do. Okay, what you're saying here is you want to apply these resources to this machine. And this machine is in here. And what you're saying here is I want these values, yeah, applied into this logic. Okay, and this is exactly the way things that happen in Terraform with their variables versus main files. Ansible that sets up inventory and group variables, and we're looking at the roles and tasks. Kubernetes. This is a well understood pattern. This is a well understood pattern. Okay. So what we can do here is we can change the deployment, yeah, without ever changing the logic. Okay. And this logic we've set up in this case for our domain controller. Okay. Right. So now let's just make sure I've got those saved. Save that. Save that. Okay, now we're going to dive back into the terminal. Right, so we've already run our test, but let's run it again. Pre-flight. There we are. Oh no, we're in baseline, aren't we? Okay, baseline.test.psd1. Okay, test paths must be valid. I've made an error in there. And indeed, I have made an error in there because it is not PSD1, it's PS1. Okay, right, there we go. Right, so we've got some stuff to fix in here still. So we've run the test. It said expected strings to be the same because the computer name should match your configuration. Okay, so our computer name should match our configuration. So it's saying it's expected BBDCO1, okay, but it's got win blah blah blah. If I just type in host name now, okay, we can see we've got that here. Okay, and it's telling us that there's an error. Time zone match is declared intent in all nodes. Okay, and Windows time service is already running. Okay, I expected that anyway because that's the nature of it. Okay, right. So now we need to run these values. Okay, let's just clear that off. Now I'm running this on a machine I don't mind changing host names to. I mean, you can just transfer the code that you're running, save it, push it up to Git, transfer it back down. Okay, but let's do the run build now. Oh. Run build. Okay, and here we go. It's compiling those things. It's doing it. Okay, you're about to be signed out, so this is going to shut down and reboot me out. Hold, please. Okay, so there we are. It's booted me back out and back in. So let's open my terminal again. Run as administrator. Okay, and it's brought me back into where we were before. And if I open up code, now what happened there was that was a reboot. Okay, and we could see there that the operating system handled that because that's how we configured the local configuration manager. So it would handle reboots, okay, especially as we're moving, and sometimes our scripts will need to continue post reboot, okay, which we can see that they do. Okay, 1 second. It's just opened in the wrong folder, that's why. CD dev repos and com. Okay, now code. Okay, so that reboot was part of the stuff that we'd done, and we'd configured that in. Is it the one shot? The one of the one shots here. Okay, which is the helper script which invokes the networking stuff and the LCM that we needed to configure. Okay, right. So anyway, back to where we were. This is what we'd done. Okay, we'd said we wanted our computer name to be BB01. We wanted our time zone to be GMT. We wanted to be sure we're at Windows 32 time and check the other stuff. So the first thing I think we should do is rerun the test. Okay, let's let that run through. Okay, brilliant. There we go. We can see now that the host name matches declared intent with all nodes. Time zone is running. Windows time server is running as well. Okay, things I hadn't added into the baseline test. Okay, you can test those manually as well. Okay, because we can now run our Windows get feature list. Okay, so get Windows feature minus name AD domain services and rsat adds. Okay, right, so we've definitely got rsat adds. Have we got Windows Active Directory? Let's run the build again. It is idempotent. We should see if some changes are being made. Okay, the thing we can do as well is we can check back in our evidence files. Okay, so we can see what's been going on here. Okay, so it ran the moff file. We can look inside the moff file. Okay, and here we are. So this is what it's saying. We can see everything's going in there. Okay, everything seems fine within the moff file. We've got that there. Okay, but again, okay, we can go back and we can have a look in the event viewer on Windows log to make sure we see what's happened on there. Okay, so let's just chuck that in. Okay, and we've got detailed loggings. LCM was shut down, has successfully run. So we've got a successful run error. Let me just check for errors. Okay, it looks like we've got a couple of errors in there. So let's just go back and check those out before we go ahead. Okay, the way that we can attack this, if you like, and the way that we can do this is we can go into our event viewer. Okay, run as that as administrator. So this is just looking into the Linux, into the Windows logs. Okay, applications and services logs, because that's where we're sitting and working within. Come on, load up. It'll load up. Taking its time. Applications and services. Ah, there we are. It just took its time waking up. Right. Okay, so applications and services down into Microsoft, expand down into Windows. Okay, and then if we just scroll down, we should be able to find DSC. It might help if I opened it up a little bit. There we are. Okay, and then if we go into operations, which is the operational side of it, we can see that our error is there. And it's telling us exactly what happened here with that error. Okay, Windows tends to do things by event IDs. Okay, and it looked like there was a wrapper missing from there. But, okay, we're looking at the way the logs were run on the end server. Okay, so we can manually verify whether our stuff was installed or not. Okay, and if we go to Server Manager, open that up, and this is where we can verify things through the GUI. Okay, because even though it's come back with that error, we can see here that we're at that point of waiting to promote this now to a domain controller. So we've got to that point of our baseline is ready to go, but we're not quite at that point of promoting it yet. There's still a few things we need to think about. Okay. And that really is the next step we're going to move on to. Okay. So now we've gone back through that. So we've applied all of those elements to our baseline. We've got those up and running. Okay. And we've put those in place and we've got everything where we are. Okay. So let's just go back now and dive back into our system, into our code base. Okay. And we can see where we were. All right. So yeah, so we've looked at the logs, we've checked that, and we've evaluated the logs. We've looked at elements, we've made sure that things are in place. The host name has been changed. Okay, as we can see, it's now BBDC01. Okay, have I got the history in here still? No, not quite. But in our event logs, okay, we can see down here is that it was telling us very nicely that a reboot is needed. Okay, and we've got the same similar element there. Okay, right, so where were we? Oh yes, here. Right, and we've also got a whole bunch of new evidence which has come in place. So there's the results of our pester tests. Okay, we've got our transcripts and our command line debugging, so we can see what we run and what we needed to capture. Okay, we've got our moff file, okay, which is there, and we can see that it's brought through all of the elements that we needed to install within there. So now let's go back and run through our checkout routine. Okay, so this time, all right, we're now at baseline configured. So let's put this into another branch, Git, excuse me. Okay, so Git check out -b server baseline configured. Okay. Oh, capitals, look at that. Okay, so that's switched to the new branch, and we can see that with Git branch. Okay, so we've moved from pre-flight verified into server baseline. We're going to chuck our files in that baseline. Okay, I expected that. That's fine. Okay, now we're going to commit git commit -m. Okay, right. So this time I'm adding a feature. Okay, all nodes .psd1 added. Right, hang on a second while I type this in. Okay, so that's typed that lot in. As again, I've said, it's better to be detailed about this stuff. Okay. Oh, I am so not going home well with my typing today. Let's have a look here. Again, capital again. Git commit -m. Okay. Fatal error back from GPG, but I suspect that's just waiting for it to spin up. Yep, there we go. So now let's put in my passphrase. Okay, failed to write. Try that again. Yes, okay, this time we've done it. Okay, from cached credentials. All right, so now we've got that feature in there and everything we've got there is done. Okay, right. So now we can move on to getting our system ready for our pre-DC promo setup. Okay, so that's where we are. So the next thing we really need to be moving on to is onto our DC promo. Now I'm going to come back to that in a second because we've not actually pushed anything back up to GitHub for a while, and I just want to show you that cycle a little bit before we move further. Okay, so here we are again at the command line git status. Okay, that just tells us we're on branch, server baseline configured, which we are. There's nothing to commit because we've just done that. Okay, and we can see the same thing here. If we look in here, this is our source control. Excuse me, there's nothing in the staging area, there's nothing to be added. We're on our server baseline, okay, which we can see that in there. Okay, we haven't actually pushed anything back up to the server as yet, like I said, but let's have a quick look at the Git graph. Okay, we can see there, all right, and that's where we're at with our things. So we've got our main origin, our initial commit, our checkpoint, okay, for our pre-flight checks, and this is our baseline checks, and they've been done, okay, and we can see that. Okay, so now there are some things we can't do inside of VS Code, okay, and there are some things we can do, okay, and we can publish the branch inside VS Code. Okay, so this time I'll publish it using this. Okay, commit, we can see that. Yes or no, it's up to you. I like to manually control it a little bit. Okay, but the other thing we can do now is we can bounce back out to our repository. Okay, and we can see inside the repository, there's our DSC files. Okay, but we could, sorry, I'm looking in the main there. That was my fault. Okay, let it refresh through. But we can see here, this is what you get for running inside a virtual machine whilst recording and everything else. Right, let's go back to the root of that. Okay, we can see here that we've got a recent push onto a branch, and we can see the branch there, server baseline configured. Okay, and I can look in there now at, I would have been added in my documentation in here. I'd have been showing me how to run through it. I'd have been writing it up nicely. Okay, and you can see here, it says here, this branch is 2 ahead of main. Okay, so we can go back in there and then we can see inside DSC configurations, student PS1. So, excuse me, that all of the elements that we've put in there are in there. And likewise, our data file, okay, is everything that we put in there as well. Right, so that's us pushed back up there.